Hello everyone, welcome to our JSM 2001 talk on the education and pedagogy of domain-specific learning materials using learner personas for the teaching and pedagogy session. First, I'd like to thank my committee chair, Anne Brown. She is an assistant professor in biochemistry and data science. On the biochemistry side, she studies molecular modeling and drug design. And on the data science side, she studies applied data science and education. She runs the Bevan Brown Lab in the biochemistry department and runs the Data Bridge Lab at the university libraries. I am Daniel Chen. I am a PhD candidate at Virginia Tech studying data science education and pedagogy, mainly in the medical, biomedical, and health sciences. I was an RStudio intern in 2019 where I worked on the Grade This package, which is a code grader for LearnR documents. I'm also an instructor for the Carpentries since 2014. I am recently a trainer for them and also the community maintainer lead. I also run a lot of Python and R related workshops. As far as educational materials goes, I have a book called Pandas for Everyone, which is mainly around the data analysis side for Python, and I have a couple of accompanying videos for them, as well as a video for Git. This talk is around another set of educational materials for my dissertation work for data science in the biomedical sciences. Let's first look at the current data science education landscape. Data science is not a commodity. The content is not really an issue. What can be done is having domain experts help learners improve on data literacy. If we look at a lot of the data science courses, specific courses around data products and data cleaning are really missing. And we can use domain experts to fill in those knowledge gaps. So why does domain specificity matter? Well, essentially, the more relevant a topic is for you, the more you're able to learn, and you have this ability to create feedback loops for a self-directed learner. So now the question is, how do we identify our learners? One way we can do that is trying to figure out what do our learners currently know. You can do that with using something called concept maps, which allow you to map out all of the concepts related to a particular topic and how they relate to one another. And this helps you with lesson design in the sense that you can chunk up different portions of this to help you teach and pace your work. Something similar to concept maps you can use is something called task deconstruction, and all of these pertain into the Dreyfus model skill acquisition from novice to competent practitioner to expert. They all essentially have different nodes in the concept maps, and then if you're an expert, different or more connections between the nodes in our concept map. And so one way we can look and figure out what our learners know is to create a survey. So part of our work is using the materials from the Carpentries, How Learning Works, and Teaching Tech together to create a survey. The survey comes into 8 different parts where we look at 4 of them to create and try to figure out who our learners are. Those 4 parts compose of 16 questions, and if we cluster on them, we can actually go and, using the demographic information from our survey, create a set of clusters. In our case, we created 4 sets of personas: Claire the clinician, Samir the student, Patricia the programmer, and Alex the academic. A persona is a fictional character that contains a learner's background, relevant prior knowledge or experience, and their perception of needs, as well as their special considerations. And we can use parts of our learner survey that we just gave out to our learners to fill out the information used for their relevant prior knowledge or experience and their perception of need. And then for everything else, we sort of fill out those questions, some of it using the demographic information to create a more complete fictional character. And now that we have an example of a learner persona, when we start and work on creating our learning materials, we can then say, oh, what would Claire the clinician do with this set of materials? Or what would Claire want from our learning materials? And so now that we have our learning personas, we can go through the process of planning the learning materials. For our particular set of learning materials, we have 8 learning objectives. Mainly, they are going to be focused around the tidy data set and how cleaning and processing and identifying different components that make a data set tidy. And then once we have a tidy data set, we can then go through analysis, plotting, and fitting models. The learning objectives that we came up with follow Bloom's taxonomy, and that taxonomy of verbs on what it means to be an effective set of learning materials and what we want our learners to get out of our learning materials. One thing to keep in mind is when we are creating our learning materials, we want to start from the base knowledge and remembering tier and move them up towards the application tier for our newcomers. And so once we teach them something and have them to apply it, we can then go back down to the pyramid, teach them something else, and then have them apply that new bit of knowledge to another topic. So this taxonomy, even though it shows up as a pyramid, has a lot of cycles in it. So we focused our materials around tidy data. Data is messy in different ways, but we know that most tidy data sets have very common and similar features from one another. So one example that we use from Hadley Whitcomb's tidy data paper is this tuberculosis data set. And the thing that you'll notice here is in the columns, the gender and age group are all being contained in each one of these counts for tuberculosis for a given country and year. And so the way we would go about tidying this is to first we would have to do a melting operation or a pivot longer operation to get this data set on the left to get a single column that contains our gender and age group. And then once we have that, we can split off of that first character in this example to get a column for gender and then another column for our age group. So this pivoting between our data set from long view and wide view is one of the key components that we want from our learners when we're trying to create data science materials. And so an example data science problem that we use as our summative or final exam question is this case study of looking at CMV, so cytomegalovirus is a common virus that normally does not cause any problems in the body, but it can be of concern for those who are pregnant or immunocompromised. So how would they go about transforming this data set, knowing that there are other factors like the donor status that contributes to CMV reactivation? And so given that data set, what are the skills that we want them to learn? So the first thing, they want to be able to load in the Excel spreadsheet. So just loading the Excel spreadsheet requires a few things that we would have to go through, mainly how to load up a library, how to call a function, how to use that function. When we then get to the point where we are about to load our library, we have to know which library has which functions, knowing about the path and how we can call a particular file and not just putting in absolute paths, but also recognizing what is a relative path. That also means that they would have to know about working directories. Then we would have to show them how to assign variables and create new variables. The next thing that we would want them to do is sort of explore the data set a little bit. So filtering data for individuals over the age of 65. In our current example, they would have to know about pipes, filtering data and Boolean conditions. And when we go through this process, we also, as instructors, want to talk and speak and pronounce our code. So in this case, it'll be dat, then filter age greater than 65. And this not only helps the students remember the information, but it also starts to reinforce the way that they would start speaking when they start coding. The next thing we would want them to do is to save a filter data set as an Excel file to send to a colleague. So this builds up the foundations for pipelines. So once we have a data set that we have filtered, how can we save that out to build a pipeline? So the output of one script becomes the input for another script, and that is how pipelines are being used. Next, we want them to recognize what is a tidy data set. So here's an example of a dirty and tidy form of our data set. And so here we would want them to know about lists, vectors, and how to select different columns. In our case, in the tidyverse syntax, they have to also know that this is going to be a pivot longer operation and how they can deal with keyword arguments. Next, if we're trying to show them how to plot data, they need to know the plotting syntax, and specifically in ggplot2, how the layering syntax works. And not only that, they would have to know which plot pertains to the data that they're working with. Finally, when we ask them to fit a model, they have to know about the formula syntax, how to look at the results, and then how to pull out the results. So in our current case, once we get the coefficient table out for our logistic regression, we can then exponentiate the coefficients so we can talk about our results in odd ratios. So originally, when I first approached this problem, I thought since this all revolves around programming, that we should really start pulling from computer science education. And computer science education really has a lot to say about how we teach learners how to code. But it is different from computer science. So this is an example of a computer science question. And you can see that the question that is being proposed has nothing to do with data, but really about some algorithm to a specific data structure. So another resource you can look for in terms of this type of work is the Never Work in Theory project that Greg Wilson is working on. What can we adapt from computer science education? So one of the main things is that the data frame object is not a computer science data structure. And so we need to adapt our teaching when we are teaching data science. And so if we look at existing bodies of work, in the R for Data Science book, their main focus is getting people drawn in to start programming with R. So they focus primarily on plotting and visualization first before they eventually get to tidy data. In the Data Science for JavaScript book, you can see that the actual use of data is towards the end of the book, and then the beginning of the book revolves around manipulating web objects, which is what JavaScript is made for. The Open Intro Statistics book does focus on data as its first chapter, but then it ends up mainly focusing around data types and how data works for statistics, and not how data works and how you can manipulate and tidy data if you're given a messy data set. In the Python world, Python for Data Analysis does end up covering data wrangling pretty early if you ignore the introductory chapters. That book does go through the data cleaning steps pretty early. The Pandas library book ends up putting data reshaping and pivoting more towards the middle and end of the book. And if we look at some of the stuff that I've worked on, in Pandas for Everyone, I followed the mantra of trying to get a figure as early as possible. So we have plotting coming first and then tidy data concepts coming immediately afterwards. We sort of changed the focus for the DS for Biomed stuff because spreadsheets are so ubiquitous. We try to cover spreadsheet fundamentals and then try to get them to tidy data as fast as we can. However, when I end up teaching a 4-hour conference workshop, I try to throw tidy data as early as possible, but this comes at the cost of trying to cover more in detail about spreadsheets and concepts like that. And so the main takeaway is, if you do end up teaching a domain-specific group, identify who your learners are, figure out what they know, and use that information to plan a guided learning track. And one way you can do that is start using this survey that we have created to try to identify learner personas as a way to create your information and learning materials. The next things that we're working on is survey validation. So that survey, or the set of surveys that we're working on, we're going to try to validate them using factor analysis. There is a pre-post workshop survey that we use to address the learner's confidence, since we aren't able to grade them formally because we're trying to teach this set of materials in a workshop setting. The post-workshop survey also ties into the long-term survey for confidence and retention, because there is a common summative assessment question, like a final exam question. Another thing that we're looking at is looking at the different types of formative assessment questions and how that relates to a learner's ability to answer a summative assessment question. Last but not least, I would like to thank the rest of my committee. Dave, Alex, and Nikki have been very supportive in allowing me to pursue a topic for my dissertation that I'm very passionate about, so I can't thank them enough for supporting me as well. For additional resources, if you're interested in learning more about data organization in spreadsheets, more about learner personas, Bloom's taxonomy, and the techniques of an instructor in a live teaching environment, here are some more additional resources on that. And with that, I'll say thank you so much for attending or listening to this talk. The slides and repository are posted, and if you want to know more about the work I'm doing, you can look at my current dissertation work, which has been published through my preliminary exam. Thank you.